today for the 4th out of 4-part series for commercial heat pump water heating, design, operations, and maintenance. My name is Armando Berdiel, Technical Development Supervisor with Lighting Design Lab. Just very happy to have you guys here again, and again, following our 4-part series. Quick notes. You'll notice that you're all going to be muted. However, please engage with us in the bottom right corner of the GoToWebinar dashboard. Is going to be a chat function there. Anything you chat over, we'll see it as questions, and we'll be addressing them periodically throughout the presentation. And also, and I know Evan's going to go into this in detail, you'll please engage with us on the Slido application, or we're going to poll for some questions. So please engage. The more you put into this, the more we get out. And lastly, a recording of this webinar as well as a PDF handout of the slides are going to be available on lightingdesignlab.com, as well as our YouTube channel, Lighting Design Lab on YouTube. I'm going to give it up to Evan Green and Trevor Davis. Take it away.
Hey, thanks, Armando. Thanks for having us here. Trevor Davis will be our moderator today, so he'll be popping in every now and then to address any questions that you guys come up with. He's a lot better at looking at the chat while I'm actually presenting. I tend to totally miss questions coming in, so he'll be really helpful today. Is there anything else you wanted to add to that, Trevor?
Yeah, thanks all for joining us. You can use the chat, also the questions tab as well. Sometimes that's a little bit better option just for me. That way I can respond to you guys individually. But either one will work. I'll keep an eye on both of them. And if you have any questions or anything throughout it, please just drop it in there, and I'll address them as they come through. So thanks all.
Great, thanks, Trevor. So for those of you that didn't come to the session last week, we'll be reviewing that session, and I'll give you a little bit more about my background as well. So I'm a research and design engineer at Ecotope, and we're a research and design firm in Seattle, Washington that is focused on the decarbonization of buildings. So we like to electrify everything and really focus on energy efficiency. So we're not adding a big strain to the electrical grid, but we're also getting the burning of natural gas out of buildings so we can make our air cleaner and reduce the carbon emissions in our buildings. So today we're going to be talking about commercial heat pump water heating and how we're going to maintain the operation of these heat pump water heaters, and I'll go a lot more into depth about that today. But first, we want to introduce this Slido app, which is a way that we can seek some really valuable feedback from you today. And to use this app, we can just go on slido.com on your PC or on your cell phone, or there will be QR codes that you can scan with your camera on your phone. And then we can send you questions that you'll be able to answer to provide feedback to the content I'm talking about today. And then maybe give me a little more information on your backgrounds, as well as what other content you might be able to add to our discussion. So we'll start with our first Slido questions, and this will be an introductory survey so I can learn a little more about you all who's listening in today. So go ahead and either scan the QR code with your cell phone or go to slido.com, and you can enter this code design4 when you're prompted for that. And I'll enter the survey, and we'll give you a little bit of time to answer these questions as they roll in. And I just kind of want to seek who we're talking to today, so I might be able to tailor the content a little bit more clearly to your application.
Yeah, just to add on there, I know someone just asked to design for code. It should be working. Okay, give us 1 second then. Sorry, some people are saying that no such event is happening. Give me 1 second, check that for you.
I'll try myself here as well. All right, so if you found that it's still not working, try to go ahead and log out of Slido or close your browser, and then log back in and enter design4. Maybe it's just that the survey wasn't open by the time you got on there. Okay, we have someone listening in from San Diego and Kirkland. So we're on the West Coast so far. There's great heat pump installations all along the West Coast. So really, really viable area for these products. And I'm presenting from Eastern Washington today. I work remotely for Ecotope, and I found myself in the northeast corner of the state when I initially worked for Colmac Water Heat out of school. So a lot of the experience I'll be bringing today has to do with my work with contractors and installers based off Colmac's equipment. You'll see quite a few Colmac pictures in here that have been installed through Ecotope and coordination with Colmac. And so I'll kind of be talking about my personal experience with a lot of the things I've seen down the road in these installations where we might get calls back based off how well these units were maintained and initially installed. So we've seen kind of a lot of direct feedback based off how closely the installer was coordinating with the manufacturer designer during the install, and then how that followed up through maintenance. So we're looking at some.
Oh, sorry, I'm gonna just hop in here. I know yeah, people are saying that the Slideto is not working. So it looks like the code is not working, but if you just open your camera app on your phone and hold it to that QR code, you'll be able to access it. So it seems like Slideto is having some issues there. Or if you want to participate, just like drop it in the chat, and I can also just read that off to Evan. So apologies that design 4 is not working. We'll follow up with Slideto to see what's happening there. But if use your QR code, that should be able to get you where you need to go. So yeah, apologies for that, but let us know if that's not working for everyone. So thanks.
Yeah, sorry about that. That's probably why I missed it too, is I just scanned it with my phone really quickly. iPhones are good now that all you have to do is open the camera and point it at a QR code and it'll pop open with the link. So some, but not all of you attended the first 3 sessions, or you attended some, but not all of the first three sessions, and some attended all of them. So great. Hopefully today will serve as a good recap of the first 3 sessions, as well as provide you with some additional content to help you create some maintenance and operation schedules for this equipment. And some questions about today's session is all about maintenance. We will be handling a large portion of this will be about actually maintaining the equipment from the heat pumps to the surrounding components that help it work, as well as a little bit more detail into the installation and coordination there, and a recap of the rest of the series. And what's the typical maintenance cost compared to gas water heating? That's a really good question, and you'll be pleased to find that it's not very costly or time consuming to maintain this equipment, because there aren't really wear components on this equipment. So in terms of maintenance cost compared to gas, it's probably about the same, because all the components surrounding the equipment is the same typical equipment you'd find in a gas water heating system. And so to review what we talked about in session 3, we focused on how you are going to take a design drawing from an engineer and translate that into an operable system through, first of all, finding the right subcontractors that have some good quality traits to be able to implement a heat pump water heating system that they might not have installed before, which is really important, because you want to be able to find subcontractors that are eager to learn about these systems and not those that may just think they already know everything there is to know about plumbing. So that's really important there. And we also talked about the detailing of the equipment and working with the manufacturer and the designer to figure out how you need to accommodate your equipment to make sure that it fits the designer's intent. There's little tweaks and details that you need to think about when it comes to how you're pairing your storage and your other components with the heat pump water heater, as well as any additional options you might need to make that water heater function in the context of the designer's sequence. And we also talked about the verification and purchase of the equipment. Since this is a quickly evolving technology, there's often going to be data or requirements that will change and evolve with the evolution of the equipment itself. So the equipment that's been spec'd in the design may be slightly different than what you'd receive if you ordered it after the full gestation period of the job. So it could be months or years later. So you want to make sure that you verify all the right information with the manufacturer so your equipment still matches what your designer intended to install into that system. And then we talked about the installation and startup of the equipment, which is where we'll have a lot of overlap today. We talked about some important things to keep in the back of your head with the installation of the equipment, especially communication is one thing that we hit on over and over again. We'll talk about today as well as all the coordination between all the different parties to make these systems successful. And so a quick check-in here with Slido. Go ahead and scan the QR code if you haven't logged in yet.
Yeah, and the design for should now work. I fixed it, so you should be able to do design for now, and everyone should be able to get there. So let me know if you guys can't get there. So
great, thank you, Trevor. See, this is why it's really important if you have a webinar to have a high-quality moderator here. Any additional questions, Trevor's always right on top of, and I definitely wouldn't have been able to figure out the solution to Slido while I was talking about this.
We also had one question too. Well, a couple people said they were from Seattle, so thank you for those responses. Then someone asked they're interested in how much compressor cycling is too much. I think we were talking about some questions they brought with them today.
Yeah, so we want to ensure nice long run times with the heat pump water heaters. One, because it takes a toll on the heat pump every time it starts and turns off, because the system has to kind of reach that homeostasis that it likes to operate in, but it takes a lot of energy to get there. So the longer it runs, the more efficient overall your cycle will be, and the less wear you'll have on your compressor, because it's not trying to ramp up and try to get those refrigerant pressures to where they want to be. So in terms of like how many cycles is too much, or how often is too often for your compressor to be starting, a rule of thumb is, like, in worst case design conditions, maybe like a 10-minute cycle for your heat pump. 10 to 20 minutes is kind of a minimum, but you don't want that to be the operation of the entire lifetime of the heat pump. You want that to be kind of a worst case condition where it's seeing the highest air temperatures and lowest water usage that results in a really short cycling time, right? The longer the cycle times, the longer your heat pump's going to last, and the more efficiently it will operate. And so the confidence in this process that we went through last week, we have about 62% that are kind of confident in the process, and then we have a little confidence in more, and then not very confident in the rest, which is totally fine if you feel like you couldn't just go through this entire process without a hitch. That is kind of underlines the importance of talking to others that know a lot more about the process or the equipment or the design. So talk to the designer and talk to the manufacturer and their rep to make sure you're covering all the bases that you need to during the installation of this equipment.
Yeah, and Evan, I think this one comment sort of really segues into that. Someone said that the problem with the process is my organization tends to use architects and engineers who don't know about heat pumps. So I think that really just sort of ties in with what you're saying. It's like it's a new technology, they're not really quite sure of it, and so you're right. I think that is definitely a barrier that we're trying to overcome by having these trainings. So thanks for the comment there, Matt.
Yeah, great. We will talk about that a little bit more in this presentation, how you can kind of accommodate any information that your engineer might be missing during the design process, because yeah, like you said, it's new to a lot of engineers as well as installers. So the engineer might not have thought through every step of this process as well. So yeah, it's good to educate yourself and educate your team as much as possible while you're implementing this equipment. And so the key question we're going to try to answer today is, how do I successfully start and maintain a commercial heat pump water heater system in its operation? And these heat pump water heaters, they can live a really long and successful life. We've seen them operate for 20 or 25 years without any issues. But to ensure that, you need to make sure that they're operating the way that they were intended to operate, and they were installed how they were intended to be installed. Otherwise, you might have some of these oversights in startup that will lead to non-ideal conditions that your heat pump's operating in, and that could lead to a much less reliable operation and a much shorter life because of things like the short cycling that I was just talking about earlier. So in addition to implementing the heat pump water heater into the system correctly, you want to make sure that you follow up with a maintenance schedule, because even though it doesn't take a lot of time or money to maintain these heat pumps, you still need to make sure you hit a lot of the key points to ensure that they're still operating efficiently and that their components are cleaned and maintained as necessary. And another thing to think about here during the startup process is your conditions might be different between startup and the majority of where your heat pump's operating. Well, you might start it up in the middle of summer when it's 80 degrees outside, but you need to follow up the following winter when it's 30 or 40 degrees and the heat pump is seeing much different conditions than when it was started up in. So we'll go a lot more deeply into these points here, but we just need to make sure we're thinking about the question of, how do I successfully start and maintain the operation of these systems? And to start off here, we will talk about a case study that Ecotope was involved in the design of, and this is the building Elizabeth James in Capitol Hill, Seattle. So here's a picture of Elizabeth James House, and this is an elderly low-income housing, so it's important that we have reliable and consistent hot water that's served at the right temperature for these more delicate occupants. And this was a very successful installation, but there was a very different set of challenges with this installation than what we went through last week, which was 23rd and Jackson, or Jackson Apartments, which was a new multifamily building. So since this is I might not have mentioned, this is a retrofit, we're fitting new equipment into an existing building that has a separate set of challenges. So here's the plumbing schematic of Elizabeth James, and you can see that we have our primary heat pump water heaters that are heating all of our cold city water up to temperature, and they're paired with these 3 primary storage tanks. So they're charging this storage with about 150 degree water, and the cold water supply is coming in, either coming into the bottom of the storage if there's a lot of usage, or it's going to the heat pump water heaters to be heated up to charge this large massive storage. And so whenever there's heat, the second system that's operating a little bit separately, but also combined in a really unique way that I'll go into here in a second, is the hot water circulation reheat, or the temperature maintenance system, as we call it. And this system's really important because we have hot water supplying the building, but if there's nobody using that hot water, all the water in the pipes will cool down. So we need to consistently circulate that hot water through the pipes to make sure we always have fresh hot water available to the occupants. So that water is circulating, but it's coming back at a relatively high temperature that's cooler than the occupants need, but warmer than the heat pump water heater would ideally like to heat. So the Sandon heat pumps that we're using in this application really don't like to heat warm water. They're really inefficient and less reliable that way. So that warm water returning from the building is actually coming into a separate tank that has electric boilers or electric instantaneous water heaters heating and making up for those losses. But they don't actually have to heat the entire, they don't have to make up for the entire heat loss in this circulation loop, because you'll see as soon as hot water is sent out to the building, we have this makeup water coming in through to serve the building. And so this is 150-degree stored water that the heat pumps have heated really efficiently, and it's making its way through this tank before it goes out to the building to be used. So as it makes its way through this tank that is accommodating the warm, sorry about that, the warm recirc water, it's actually passing through and heating up that coolish, warmish water as it passes through. So if there's sufficient usage in the building, just this 150-degree water passing through this tank is going to be enough to heat up this temperature maintenance tank without the use of any additional electric heating. So it's really cool that we use that in a way to as kind of a secondary heating source to allow these heat pump water heaters to manage the heating of both the primary hot water supply as well as the temperature maintenance heating load, and all doing it in a really efficient way where the heat pumps only ever see really cold entering water. So if we take the cartoon filter off of this piping schematic, here's what you'll see in the actual building. And starting with the 4 Sandon heat pump water heaters that we have placed right outside the building, and they are piped in parallel with these insulated pipe hangers to make sure that we have minimal heat loss coming from the pipes that are located outside. And this isn't insulated yet in this photo because it's a primary installation picture or a kind of a rough-in, but the insulation is added here and you won't have any thermal breaks because of these insulated pipe hangers. So that's really minimal heat loss. And then from there, the hot water is charged into these 3 primary storage tanks, which are plumbed in series to allow for maximum stratification inside those tanks. So the plumbing the top of the first tank to the bottom of the second tank and so on will allow this tank to act as one tall storage tank, so you can charge the top of that tall tank with hot water and the cold water remains on the bottom. So these heat pumps are paired really carefully with this primary storage to ensure that it's operating as efficiently as possible. And then from this primary storage, we have the 150-degree water flowing through our swing tank, our temperature maintenance tank, and then out to the building. So this hot water is flowing through this final tank that's also receiving circulated return water. So the overall temperature of this tank is maintained above what we need to serve to the building. So it's always warm enough. And then we have these 3 electric resistance water heaters that were original equipment in the building, but they're now being used as redundant heating as well as a temperature maintenance heaters for those times of low usage when we don't have the hot flow from this primary storage warming up this temperature maintenance tank. And because we implemented this system into Elizabeth James, they saw an energy savings of about 70% in the domestic hot water system. So that's huge, and that is about a kilowatt hour per day per person in this apartment, in this building. So the key takeaway from this case study is we don't want to abandon existing equipment in retrofits because it can be recycled into the new installation. We actually saved a lot of project cost here because we were able to utilize those existing electric heaters and the existing tank to implement into the temperature maintenance system. So now we're going to talk about, we'll call it installation light, because I don't have time to cover every single step in the installation process of these heat pump water heaters because we're only operating a 2-hour session here. And it's a little bit different depending on the manufacturer you use. So we want to make sure that we're covering the really high level points here, but you still want to coordinate with the manufacturer, designer, and the rep to make sure that you're hitting all those points that the specific piece of equipment you're installing needs to be accommodated for. So the three main points we want to cover today is we need to understand the design of these heat pump water heaters. We need to ensure the proper coordination between the installer, designer, manufacturer, and all the subcontractors that are going to be touching the heat pump water heater itself and the components around it. And we'll talk about some main points of the physical installation and what you need to keep in mind while you're planning this out. So the first part of this is understanding the design. And I know it's going to be extra time and extra money to fully understand this design as a team up front, but it will definitely save you money in the long run, because any of these issues that you can see pop up during the design or the detailing phase before installation are going to be a lot less expensive to accommodate than actually reworking the system once you find it out the hard way later. So we want to make sure we minimize the amount of oversight through proper communication of everyone on your team. And there have been jobs where I've gone back and forth with engineers and installers for months after pretty simple controls accommodations were overlooked as part of the design and detailing phase, but were really difficult to correct after the entire system had already been installed. So you want to make sure that what I like to do is have a coordination call between all the different parties, all the subcontractors and the designer, and have the designer actually walk you through all the components of the system and how they're interacting. And if the designer isn't able to answer any questions or fully walk you through the kind of the flow and how these heat pumps are being accommodated, that's when it might be really important to bring in the manufacturer's rep or whoever this designer was talking to come up with these base drawings. If they've kind of put a heat pump water heater into their existing boiler schematics, that's when you want to make sure you get a lot of backup information and work with the designer to ensure that this system's actually going to work for the application you're putting it into. So as part of this installation practice, I kind of just touched on this, but you want to make sure that these heat pumps are being treated as heat pump water heaters and not as gas water heaters, right? There's a lot of installers that have a lot of experience installing gas water heaters, and they've come up with a lot of best practices that may enhance these systems beyond what is actually stated on the design. And that might include things like tank connections or maybe check valves on makeup water lines that weren't actually in the drawings. And these have all been practices that have been really successful in the boiler installation that weren't completely necessary to talk to the engineer about during installation. Oftentimes it's just a lot easier to implement those practices while you're installing the equipment. But you want to make sure that any best practices that you have kind of come up with over the years, you want to make sure that those still apply to heat pump water heaters. So it's worth running by the engineer or the equipment manufacturer to make sure that the heat pumps themselves aren't operating in a way that makes those best practices less legitimate. And so another thing that we covered a lot in the last session and that we need to reiterate in the session today just because of how important it is the coordination while installing these systems. And it really does take a team to install this system correctly, because there's a lot of different parties involved in installing these. If we think about an air source heat pump water heater, it has high voltage electricity running to it, it has plumbing running to it, and oftentimes it has mechanical for the air handling, in addition to low voltage control electricity that needs to be installed as well. So it's good to get everybody in a meeting, and nowadays it's usually a virtual call, You can tell that this meeting was pre-COVID because everyone's actually within standing distance talking to each other. But you want to make sure that you get everyone in the same physical or virtual room to talk over any overlap between these install points and how this can all mesh together to both schedule and physically install these things in proper coordination. And as part of this coordination, you want to make sure that you are proactive and not reactive, right? Walk through the entire process, understand who's going to be in charge of what, and just make sure you have a really solid plan going in before you actually put any equipment down on the floor. And as part of that coordination, I'll give you a little example of how Ecotope has been involved in these installations, and it's been really successful so far. So first is this site meeting that I've been talking about, where everyone gets in the same room or virtual room even, and just talks about the steps of the entire installation. The next step in Ecotope's commissioning process is to go onto the site during the rough-in process, where it's a lot more easy to see any physical obstructions that the building might have after the equipment's in that weren't totally clear on the drawings. So hopefully there's no corrections that need to be made at this point, because the drawings have and the design intent has kind of laid it all out. But it's always good to check physically that everything makes sense in the space that it's operating in. And then the third step in this commissioning process is going to the site to do startup and functional testing. So there's kind of a couple different parts to this, because oftentimes there's going to be a factory technician doing equipment startup. So the functional testing of the entire system is going to rely on the completion of that startup process. So you want to make sure, as a designer or a commissioning agent, that you're coordinating with the installers and you're coordinating with these factory technicians to make sure that everything's up and running by the time you get there for the functional testing. And then the final punch is the fourth step, where you'll verify that everything's operating as intended to ensure the efficiency and reliability of the system, but also make any corrective actions that you found during functional testing, because often there's some little things that will need to be tweaked to ensure that all the different pieces of equipment operate correctly together. And the last part, the last main thing you'll need to think about during this installation light process is what we need to actually consider for the physical installation of the equipment. And so a few points that have kind of been what I have found to kind of be pain points, or things that people need to reconsider during this installation that they've had to plan around, are things like the actual access to the mechanical room or the roof that the heat pumps and the storage tanks are going to be installed into, right? So if it's a mechanical room, can the tanks and the heat pumps actually fit through the doors of this mechanical room, or do you have to install them before construction's complete? Or in a retrofit case, do you need to actually remove components of the heat pump or remove the door frame or the doors themselves to be able to fit the equipment into the room, into the physical space? And have we, if it's on a roof, have we scheduled a crane to overlap with the actual delivery date and installation date of these heat pumps? And when it comes to crane scheduling, you do want to follow up with the heat pump manufacturers to keep up to date on the lead times that you'll see with this equipment. If lead times change and your crane is scheduled to be done operating by the time the heat pumps actually arrive, then the crane's not going to be helpful for that installation, and you're going to have a hard time recouping those costs from the manufacturers or reps to recoup the cost of the crane itself. And another thing to think about here is the seismic restraint of the equipment. A lot of excuse me, a lot of heat pump water heaters are pretty low to the ground, so they might not need physical seismic restraints aside from the mounting points that they're bolted down from. But there's often vertical storage tanks that you need to consider the seismic restraint for as well, and kind of fit that into any maintenance clearances that you're planning for this equipment. And what about the maintenance and electrical clearances? You want to make sure that throughout the entire design and installation process, you're thinking about how people are going to get in there after the fact and actually maintain this equipment. So that comes down to the actual layout of the mechanical room that is early on in the design phase, as well as any additional obstructions that might come up during the installation. So after going through this installation light in our webinar today, I want to check in with you and gauge what your key takeaway is regarding installation light. This would also be a good place to drop in any additional information based off the experience you have, either installing heat pump water heaters specifically, or mechanical or plumbing equipment that could be related to this process.
Yeah, thanks, Evan. If anyone has any problems with the Slido with that new design for code, let me know, and I can try and do some more troubleshooting for you. But yeah, we did have one comment earlier, but just someone was just basically saying for that retrofit that you have, basically saying that was a good use of that electric water heater. You know, basically being able to keep it in the system, but still being able to use it as a backup. So I think, you know, we've seen that from a few different ones that you've shown, is that you don't necessarily need to throw everything out, but if you have ones that you have as sort of a backup emergency, it's nice to sort of keep that as part of it.
Yeah, I know as designers, we're always trying to figure out how to make these systems kind of less expensive for the owner, but still really efficient and effective. So that's one really great way in a retrofit to save a lot of project costs, and kind of lets you be creative about your design as well. How can you implement this additional equipment to actually enhance the heat pump water heating system? And these are all really great key takeaways about installation best practices, about gas water heaters, that you need to make sure that they're applicable and you need to check on that, as well as checking for free installation details. Yeah, manufacturers' manuals or their reps even, or the manufacturer's engineers themselves might have really gold nuggets of information during your installation. So definitely keep them in the loop while coordinating your installation process. And you want to make sure your plans are all planned out. Yes, the more time you spend up front, the more money and headache you're going to save later by knowing what you're getting yourself into in installing this equipment. And the communication is definitely a part of that. And trust but verify is a great term to use here. You don't want to assume that the engineer that you're working with is wrong, but you also want to make sure that you're getting all the information out of them you can, and maintain a really open dialogue to ensure that all of the really important points of this equipment is accounted for. And yes, don't assume is the last one that came in here, which is a really strong point as well. So after we've installed this equipment, we're going to need to think about how to maintain it. And this is really important. And I definitely just said that wrong. It's not about thinking about how to maintain it after the installation. It's thinking about how to maintain it throughout the entire design. But then we need to make sure that that's properly implemented after the installation and startup, to make sure that this equipment can operate efficiently and effectively for a really nice long life. Right, so we have maintenance needs that are going to vary depending on the equipment that you're using. So you want to make sure that you read the equipment manuals, and if possible, you can use monitoring exercises to ensure that the equipment continues to run properly as well as have a really solid schedule to check in on this equipment to make sure it's still running as you expected. And a lot of times there will be warranty requirements for this equipment that ensures that you've followed this maintenance schedule. So anything that breaks down on the equipment, the manufacturer wants to make sure that this is actually an equipment flaw and not just the result of poor maintenance, which can lead to premature equipment failure. And so there are different maintenance intervals that will depend on the site conditions. So you want to make a note of the location that this equipment's installed into, because there are different things, there's different context around each site that might drive really different intervals. For example, you might be in an agricultural area where you plan on changing your air filters every 6 months on your air source heat pump water heater. But if there's plowing in the spring and in the fall, that additional dust in the air and any sediment in the air might really bog down those filters a lot more quickly than you'd anticipated if you were in a different environment where you don't have that agricultural background. As well as one site condition that's really important to mention, especially in Seattle, is in marine climates, you want to ensure that you're inspecting your air coils on your heat pump water heaters to look for any corrosion or anything like that due to air that's a lot more harsh to mechanical equipment. So the components that we're going to look at today in terms of maintenance are, a lot of these components overlap with conventional gas systems, but nevertheless, it's good that we're going over it to kind of reiterate the importance of maintaining these components. So the heat pumps are the one thing that's going to be new information if you're an installer of gas water heaters, but we also are going to talk about the maintenance of the storage tanks and the temperature maintenance system that's reheating that circulation loop, and the controls that bring all of this equipment together. So with that, I'm going to pause for questions. If anyone's had anything they're curious about up to this point or would like me to clarify anything, I'd be happy to do that here.
Nothing's coming on the question side either, but please feel free to drop those at any time. If there's a portion that Evan's going over that's not quite clear, you want more clarification on, we can definitely stop and address those. Don't want you to have to wait until all these ones. We can definitely do them as they come through, but definitely do that.
Yes.
Evan, I would maybe ask, is there a specific sort of portion of that maintenance, of the initial setup that's sort of the most challenging? Is it sort of like the communication portion of it? Is it just like sourcing the right equipment? Is there a certain point of the setup that you find that you had the most sort of headaches with?
Yeah, I mean, oftentimes with a lack of communication comes headaches with all of the other components of like maintenance, clearance, and all these little details that you need to know about while installing the system. So the lack of communication, I would say, is definitely the biggest problem or the pain point with contractors or designers that are really used to kind of maybe recycling designs and install systems that they're super comfortable with. So they don't feel that they need to reach out and ask these additional questions. But it's really important. So I've found a lot of really easy to communicate with these designers and installers and just get everyone on a call. But that's kind of operating as either the designer or the manufacturer's engineer when I worked at Colmac. So people kind of wanted to hear what we had to say, so they didn't, they didn't run into any issues later. But that is where it could be maybe daunting or challenging, is making sure that you make the initiative to create that initial call and open that dialogue for coordination. And don't rely on others to do that if you don't see any coordination up to this point, whether you're an installer or a designer or even a manufacturer's rep that needs to implement this equipment. You want to make sure that that dialogue is opened really quickly at the beginning of the process to allow it to flow a lot more smoothly later. So the question here is, what does GPS mean in this context? And that is just, this is simply a roadmap of what we're going to be talking about today. So we're going to kind of be referencing back to this GPS, which is just saying where we are in providing this content of the heat pump, storage, controls, and the other components that need maintaining here. So when the existing water heaters are retained and integrated into the new system, when they actually fail, are they then replaced, or is there work to the new commercial heat pump water heater to do without that original equipment? Yeah, that's a really great question. So the integration of these heat pump water heaters in, I guess we'll speak specifically to Elizabeth James, the project here. We have 3 instantaneous electric water heaters that are paired with this one swing tank, and those heaters originally provided heat for the entire hot water plant or the entire building. So they are definitely, their primary function in this existing building is redundancy to back up those heat pump water heaters. So say if one of those heaters was to fail, then we would still have way more swing tank or temperature maintenance heating than we need with the remaining 2 heaters, but we do have less redundancy at this point. So at that step in the process, it would be up to the owner to decide, am I comfortable enough with this heat pump water heating equipment? Have I had good luck with it to rely on it to be able to cover the heat that it has been covering this entire time? Or do I want to replace that last electric heater and maintain full redundancy in case anything goes down? Right, so it's kind of application specific. Sometimes, like if you have a single water heater that is providing heat for that temperature maintenance tank, you're going to need to replace that if the original equipment goes out. But other times, not replacing that equipment may just mean you have less redundancy in a system that you have now been able to trust or become reliant on because the heat pump water heaters have been operating as intended. And yeah, any more questions that come in, if you were kind of racing to type that into Slido, go ahead and just drop it in the chat, and we're happy to stop and address that anywhere throughout this conversation. So the first thing we're going to talk about in terms of maintenance is the heat pump water heaters. And I've mentioned that this maintenance is not expensive, but it's really important to ensure that they're going to operate for a really long time and do so efficiently and reliably. There's often concern as well that a refrigeration technician might need to be involved in this maintenance. I can assure you on almost all heat pump water heating equipment, you don't actually need a refrigeration tech to maintain the equipment. There are repairs if a component fails and you need to repair down the road, that's where a refrigeration tech might get involved because they're breaking into this actual refrigerant system. But generally, all you're going to need is somebody that's comfortable working with mechanical or plumbing equipment to do some pretty basic tasks that usually would fall in the realm of just a building maintenance manager. So before we talk about what components need to be maintained, we can gain a little better understanding of the heat pump water heater refrigeration cycle. And heat pump technology has been used for a really long time, so it's a pretty fail-safe method to transfer heat. And that's the thing we need to focus on when we're thinking about heat pumps in terms of design or maintenance, is they're really designed to move heat rather than create it. And that's why they work so efficiently, is because they're harvesting that heat from the air and transferring that into the water rather than creating that heat through electric resistance or the burning of fossil fuels. So when we think about the refrigeration cycle that is going on in these heat pump water heaters, we can kind of draw a line halfway through this refrigeration loop and think about what's going on either side of it. So up on the upper half of this line that's dividing this loop into two, we have the compressor, which is its job is to pull refrigerant out of the left half of this loop and push it into the right half. It's compressing this refrigerant and causing it to have a really high pressure on the right side of this loop. And then we have an expansion valve on the other side here that's slowly trickling refrigerant back to the low pressure side of the loop. So there's constantly refrigerant being pulled out of this side of the loop and compressed into the high pressure side, and then it's trickling back to the low side. So you can see we have this clockwise flow here where we consistently have refrigeration flowing around the loop just through the act of the compressor pressurizing one side and then trying to reach equilibrium by trickling back to the low pressure side on the other half of the loop. And so why is this difference in high pressure and low pressure important in the refrigeration loop? It's because there's a, due to the characteristics of gases that this refrigerant is in a good portion of this cycle, as soon as a gas is pressurized, it will raise in temperature. And if it drops in pressure, it will then lower in temperature. So you might have seen this in practice. If you say you're spraying your keyboard off with dust off, that spray can actually gets really cold because that gas in the spray can has now dropped in pressure as you expel a lot of the gas out of the can, right? So the can itself gets really cold due to that pressure drop. I noticed it when I was paintballing. My CO2 cartridge starts to go empty, and then it gets just ice cold because it's had that drop in pressure. It's also having a drop in temperature. So what's happening here is as this compressor pressurizes this refrigerant and sees this instant pressure increase, we also have a really high increase in temperature, right? And the same thing's happening down here with the expansion valve. We have this high pressure refrigerant that's trickling through this expansion valve to a low pressure side of the loop. So that drop in pressure is causing it to drop in temperature pretty significantly. So now we can have a really cold air source on this side of the loop that's passing through a heat exchanger that we've placed on the low pressure side of the loop. And now this extremely cold refrigerant is passing through the heat exchanger and soaking up heat from that relatively warmer air. So even if this air is 10 degrees, if you have the proper heat pump, this refrigerant may be 0 degrees because we've dropped it in pressure. So now it can soak up the heat or the energy from this air through this heat exchanger or evaporator, and then that same refrigerant is pressurized and sent to the high pressure side of the loop where it can now transfer that heat to this domestic hot water. So we have a 10-degree refrigerant that's absorbing energy and then pressurizing and raising to 140 or 150 degrees to then transfer that energy back into the water. So we're able to pull heat out of 10-degree air and dump it into 140-degree water because of this clever refrigeration circuit. And that is all free energy that we're getting from this air source. And the only thing we're paying for is the work done by the compressor to actually pressurize that refrigerant. So that's why these heat pumps are so efficient, is because we're harvesting the heat from the air through these pressure changes, and we only have to pay for the actual pressurization of the refrigerant. And with that, I don't know if any questions have popped up in the chat, but definitely. Yeah. Great. So what questions do we have?
Yeah, did have one come through. Someone asked, are there any of these heat pumps running with VRF?
Yeah, they definitely are. So there's in several different heat pumps, they will change the speed of the compressor depending on the conditions they're in to only flow the amount of refrigerant necessary to transfer the heat that's available. And it's trying to explain it in terms of changing the compressor speed might be diving into the weeds a little bit, but yes, they do operate. There's different types of heat pump technology that operates with VRF, whether it's just changing the compressor speed or having several different circuits that handle different quantities of refrigerant depending on the conditions they operate in. So that's a great way for these for this equipment to operate most efficiently and only push as much refrigerant as necessary for the load to accommodate the load that it needs to. And yeah, I'll go ahead and move on here if there are no more questions, but if you just haven't had the chance to get your question out, I would be happy to move back to this slide as we continue forward and address any questions that come up there, because I kind of dropped a lot of information in the explanation of this refrigeration circuit. So in terms of how we're going to maintain these heat pump water heaters, there's kind of 3 buckets that we can drop this maintenance into, and that is inspection, cleaning, and maintaining the equipment. So in terms of inspection, there are, of course, again, it depends on the manufacturer on what components that you will readily be able to inspect. But the most common with these heat pump water heaters is you'll want to inspect the evaporator coil to make sure that there's no debris or anything like that in the coil, and there's no corrosion that would cause this coil to operate less efficiently, and then make the heat pump itself operate less efficiently because of that. And on certain heat pumps, you can easily check the actual refrigerant pressures. I was talking about how the pressure will rise on the high pressure side to drive a certain refrigerant temperature. But if the heat exchanger on that high pressure side is not allowing efficient heat transfer to the water, then that pressure will have to rise even further to push that heat more aggressively into the water. So if you see that your refrigerant pressures are at a certain condition during installation, and you do follow-up maintenance and inspection and find those pressures are a lot different with relatively same air and water conditions, then you'll know that there might be something to look at with your heat pump and something to address, most likely through the heat exchangers, but other components that you manufacture can more finely attune you into. The other thing that a lot of heat pump water heaters have that are unique to them is this metering valve that will throttle the amount of water that flows through the heat pump to allow it enough time in the heat exchanger to rise up to a specific temperature. So if the temperature set point of a heat pump is 140 degrees, this metering valve will only allow enough water to trickle through to allow that water time to rise up to a temperature of 140 degrees. And so if this valve's not operating correctly, you'll either see a variance in water temperature, or you'll see it not be able to hit that set point, and therefore your pressures will get all out of whack as well. And in terms of cleaning these heat pump water heaters, you might see actual physical debris in outside installations, like you see here with all of the leaves that have accumulated in the fall and that have been taken up into the air filter. And because this air filter is so clogged, now the heat pump can't intake all that air that it's harvesting the heat from, so it's not going to be able to operate as efficiently. There's also the Y strainers on the inlet of the heat pump that's protecting the heat exchangers from intaking any debris through the potable water supply, but all of that debris is getting caught in this Y strainer. So at a certain point, if it's not maintained properly, you will have an obstruction of water flow through the heat pump itself, and you'll see the same issues as an inefficient heat exchanger because you can't flow enough water to take that heat out of the system. So if this is plugged, some symptoms you might see is a lack of water flow altogether, which would cause your heat pump to alarm out, or water temperatures that actually exceed the set point that you've set the heat pump for. And in terms of maintaining these heat pumps, you'll want to maintain the potable water heat exchanger to flush or descale any lime or scale that has built up inside that heat exchanger. So this can be done pretty simply with a food grade descaling agent that you can pump through the heat exchanger of the heat pump and get rid of any of that scale that's built up. So you don't have to take anything apart. You just need to make sure in the design phase that you accommodate the valves required to pump that water through the heat exchanger, and then ball valves that can isolate the heat pump from the rest of the hot water system while you're doing this maintenance, because you want to make sure that this gunk from the heat exchanger as well as this food grade descaling solution doesn't get back into your hot water system. And it's about 11 o'clock, so think about everything that I've talked about so far and maybe come up with any questions. But in the meantime, we'll go ahead and take about a 5-minute break so you can absorb what you've thought about, maybe go grab a cup of coffee or a little refresh before we talk about how to further maintain the components around the heat pump water heater. So maybe we can take about a 5-minute break. It's about 11:03 on my time. So we can come back at 11:08 and dive into some great content. Yeah, I hope everyone's recharged with a renewed eagerness to learn more about heat pump water heaters. So we'll dive back in with the maintenance of storage tanks in these systems, which is really important as the storage tanks are a key factor in ensuring that these heat pumps see the water temperatures that they'd like to see.
So Evan, before, do you want to do some questions? There's a few that came in before we do that. Sure. Yeah. The first one was, is there any greater maintenance issues with VRF heat pumps?
Yeah, with VRFs, there is, say, if we're talking about space heating, for example, there's a lot more. The heaters are usually split from the condenser and the evaporator are usually split apart with a lot of refrigerant running between these two sections. So now you have kind of two different pieces of equipment that you're maintaining, and they're in a slightly different application usually. So there's going to be different maintenance requirements to these components that are more finely attuned to these different conditions. Like the condenser in a VRF heater is going to be an indoor component that doesn't see the same conditions as say the condenser in a heat pump water heater that is heating water typically outdoors. So the heat exchanger is totally different. So the general theme here though is it's still a heat pump system. So it operates very similarly, but you want to check in with the manufacturer of that equipment to make sure that there aren't any additional unique requirements for that. And like for VRF, they're still heat pumps. They change speed, and sometimes they have additional components to reroute refrigerant that need to be looked at specifically. But in general, I think the maintenance of the coils and things like that are going to be really similar.
Got it. Thanks. I see, Ian, you also had a question too. I think that you answered though, what basically was in regards to the heat exchangers with like low water air blockage. I know we sort of like went through that in the last piece. But if you have any other additional questions on that, Ian, that weren't satisfied, let us know. We can go through that. But I think that's it from my end. So thanks, Evan.
Great. Yeah, thanks for bringing those forward, Trevor. So in maintaining storage tanks, we're going to look at the same types of things. So we're going to look at what we need to inspect, which is the pressure relief valve. We're going to look at cleaning the sediment buildup from the tanks and replacing anode rods. So in talking about these anode rods, they're really important to check or maintain on a regular basis, because what these anode rods in your storage tanks or your water heater are doing is they are being sacrificial metals for any reactions in the water to react with this anode rod instead of reacting with the metal in your tank to rust your tank out. So your tank will last a lot longer if you keep those anode rods up to par, so then they can be the sacrificial metal that the reactions from the water attacks, rather than the steel in your tank that can degrade and then eventually burst to the point where you're in this situation that this nice older couple's in, where they now have a pond in their basement. So you want to make sure you're replacing those on a basis that the tank manufacturer recommends. And you don't want to wait too long, because you can see with this anode rod here, it's kind of neck down here, and you might even get to the point where this rod's breaking off in the tank and then causing additional damage by bouncing around in the tank with different water draws. So it's really important that you replace those, and that you're flushing sediment from your tank to allow or to disallow any bacterial growth that might thrive on that extra organic matter in your tank. And another way that you might be able to have a free pond in your house is if you don't check your pressure relief valves regularly, because there's two ways that these can fail. And one is if they're inoperable and they fail closed, they will not react to any pressure deviations in the tank that would cause that valve to blow and let off extra water, right, and extra pressure. So this could, first of all, be dangerous to anyone around the tank, because any really high increase in pressure that was not anticipated now cannot be safely removed through that pressure relief valve. So that turns into either the tank or the pipe surrounding the tank rupturing. And the secondary effect of that is anytime any of these components rupture, especially if it goes unnoticed, you could just have water freely running into whatever area your storage tank or your water heater's in, right? We have constant water pressure from the city, so there's nothing that's telling your water heater to shut down or block flow if there's a leak somewhere. So it's basically like turning a garden hose on and just putting that in your basement and letting it run until somebody notices. And a quick check-in with Slido. I want to hear two things that you've learned today based off our talk about installation and coordination and the maintenance of these components. Yeah, this is always an interesting time, because I know Slido pops up with the questions and then you have to kind of rush to answer them into the app before they actually pop up on the screen. So I'll give it a little bit more time here, and then we can go ahead and move on. Okay, so you have to make sure that you have access to all the components and stick to your 12-point maintenance plan. Yes, yeah, it's really important that this maintenance plan is not only known by the installer or whoever was looking into this equipment, but is passed on to the actual maintenance supervisor or contractor that's going to be checking this system down the road. Right, and you should not use general maintenance with commercial heat pump water heaters. You need the knowledge. Yeah, you can refer to equipment documentation as well as conversations with your rep to make sure that you have all that you need here. And drain tanks for biological reasons, and don't let the anode fail and drop into the tank. Yeah, that's really important here. And communication is key to have a good install, and replace the anode rods. Yes, two great points. And yeah, the sacrificial anode, some people don't even know about, but even your water heater at home often has those anodes. So even if you're not looking at maintaining a commercial system at work, or this doesn't really apply to you, think about your water heater in your basement or your utility room, and when was the last time that was actually maintained? And food grade descaling solution use and how it needs to be built into the design. Yeah, we need a way to flush those heat exchangers easily. And will I need a refrigeration tech to maintain this? Yeah, that's great things to think about. And can you actually remove your anode rod? Yeah, do we have access, or is this tank up against a wall where the anode rod can't even be pulled out? Yeah, I'm glad I waited. This was all really great feedback and great key points from today. And now we can move on to the maintenance in the temperature maintenance system. So quick check-in again. What is your understanding of the temperature maintenance system? Are you completely comfortable with what it does and how it interfaces with the heat pump water heater? Or are you still a little unsure about kind of what a temperature maintenance system is and how it influences the building? So still learning is a really good place to be here, and we'll go into a pretty strong review on the temperature maintenance system in a second here, because it's really important to understand what it's doing to understand whether it's working correctly. So here's kind of the first time in this series that we have looked at a schematic that actually flows downstream of the mixing valve. So here we see our domestic hot water system, but we also see how it might look to actually serve fixtures in the building, right? We talked about how we're serving hot water, but we need to make sure that that hot water is always fresh and hot and hasn't had time to cool down before somebody opens a fixture and wants to access that hot water. If all of this water upstream of this last fixture here has cooled, that could be several gallons that takes a really long time to all flush out before new hot water replaces that. So what we're doing is we're going to put a circulation pump here, and we're going to constantly circulate water around this loop to make sure that there's always access to that hot water. So we're not turning on fixtures and wasting all that cold water before we can get access to the hot. And since there's different distances from each branch in this system as they get sent out to different parts of the building, there's going to be a different amount of flow that's required to allow that hot water to get to the fixture in time before it cools. Right? This water that's traveling all the way to the last part of this loop is going to need to travel more quickly because it takes longer to get there and has more potential to cool after it's passed through more pipe. So we need higher flows in these farther distance loops and lower flows in the loops that are more close to the heating system. Right, so we have balancing valves on each segment of this loop so we can balance out those flows. And it's really important in the design process and a verification installation process that these aren't just basically ball valves that are throttled down to accommodate that flow. Ball valves are meant to be fully open or fully closed, so they don't reliably restrict flow in the way that a balancing valve is designed to do. And so we also talked about the temperature maintenance tank and how this water needs to be heated in kind of a special way when paired with heat pump water heaters, because heat pumps typically don't like to reheat this warm water up to a high temperature. They like to heat really cool water up to a high temperature, and that makes them operate a lot more efficient and reliably. So the components in your temperature maintenance system are really common to any plumbing system, and some that we've already talked about, like the storage and like an electric water heater. And so we're going to need to inspect the system by checking the water supply temperature, the resistance elements in the tank, and the hot water distribution system. And we're going to replace the anode rods in those tanks on a regular basis so the inner tank lining doesn't degrade, as well as disassemble and clean the maintenance valve in a manufacturer recommended time interval. So the reason that we care about maintaining these storage tanks and water heaters is because it is a really low cost to replace this anode rod, and it is extra time to drain the tank out and pull that rod out. But it's a lot more time and money to replace these tanks if they've failed prematurely. Some of these tanks don't even fit through the door of a mechanical room because they were placed before the room was actually built. And it's just a lot of labor and actual cost for the tank itself if you don't do these maintenance procedures that can make your tank last maybe a decade longer. And in terms of maintaining the thermostatic mixing valve, this is actually a really important step that's often overlooked, and you don't want your building occupants to end up like Homer Simpson here because they don't have reliable water temperature in their shower. Right, so the storage that's typically, or the water that's typically stored in these systems is at least 140 degrees, sometimes more. And as the technology progresses and load shifting is more sought after, we might even see higher temperatures, like 160 degrees or so, stored for these heat pump water heating systems. So at 140, if the shower was to increase to that temperature because of an unreliable mixing valve, you could have scalding in 5 or 6 seconds. And places like Elizabeth James, where you have a senior population that is less likely to notice this hot water, their skin is a little more desensitized. Their skin's also more fragile, so you could have serious burns because of this unreliable mixing valve. And at 150 degrees, it's 2 seconds. So this component in your system is really a life safety component because it's preventing people from being scalded really seriously. So you want to make sure that you're maintaining the operation of this mixing valve on a regular basis, because it does scale up and it does operate really poorly if you don't maintain it.
Yeah, and Evan, someone was also commenting too. So like basically saying like another installation issues, like plenty of shut off valves to isolate equipment for service. I think we had talked to that before, is making sure you're able to sort of, you know, work on those specific sections and not have it affect the whole system.
Yeah, that's a great point. You don't want to have to maintain like the storage tank or the mixing valve and drain the entire domestic hot water system, right? You want to be able to isolate this one component so the rest of the system is untouched. So that's really important during the design and installation phase to ensure easy maintenance accessibility. So, and to maintain these thermostatic mixing valves, there's almost always a maintenance schedule and what you actually need to do to maintain them from the valve manufacturer. So you're going to want to put this maintenance schedule up somewhere really easy to see, actually either in the mechanical room or in the documentation that's actually reviewed by the building maintenance person. Right? I've seen some jobs, and some relatives even have these big giant maintenance manuals that have all of the manufacturer documentation, and then hidden in there somewhere is this little piece of information that on how to maintain this equipment. You want to be able to separate that maintenance information, because anybody, not just a building maintenance person, isn't going to dig through a 300-page binder to find one page on how to maintain this mixing valve. So it's a lot easier to separate that information out and maybe even have it visible or laminated or something like that near the equipment that needs to be maintained, so it's right in the forefront of their view. And then the last component that we'll talk about maintenance on is the controls. And there's not a whole lot to do to maintain controls hardware, but it could be a valuable tool in actually ensuring the maintenance of the rest of the system. So there's two things that we can think about in maintaining the controls, and that's the hardware. And we want to make sure that there's no weather damage or water damage, or maybe damage from the sun that has degraded the hardware that oftentimes encloses all the electronic pieces in your controls equipment. But while you look at this hardware, you want to be careful, because there is electricity flowing in and out of it. So you need to make sure that there's someone qualified to do the maintenance and inspection of this. And then the other half of this inspection is inspecting the software. And that is kind of whoever is in charge of the monitoring of the equipment, or usually building maintenance or a management firm. Just check in to make sure that they're not receiving any really strange values that don't align with how the system was previously operating. And so a good rule here when talking about controls maintenance is look but don't touch. Right? These controls are designed in usually a really sophisticated way to ensure that the heat pump is operating in its optimal conditions, given all of the ancillary components around it. So in terms of hardware, you don't want to touch it if you don't know what's going on, because there's physical electrical dangers. But in terms of software, you don't want to mess with any set points or anything without coordinating with the manufacturers or the designer, and having a full conversation of why you're changing that set point from the set point that was given around the original design intent. So just a quick review of what we talked about with maintenance here is we talked about maintaining the heat pumps and the components and the maintenance of those components attributed to that. And we talked about the importance of maintaining storage tanks, both in your primary storage and your temperature maintenance system, as well as maintaining the other components of your temperature maintenance system, like the temperature maintenance tank and the mixing valve. And what I didn't mention in the temperature maintenance system maintenance is we need to ensure from an inspection standpoint that we're actually serving the proper temperature to all the different sections of the loop, right? There's often different sections of the building that have different distribution loops serving them. So you want to make sure that they're receiving consistent hot water in the amount of time that it was received in the initial installation, right? Even if equipment builds wear on it, it should not cause longer wait times for hot water in different apartments. So, and that's really important because we want to be really careful about the amount of water we're using. It's hard now that we're in Western Washington, we're going through crazy rains and flooding. There's still parts of the country that are in a serious drought, so we want to be able to save as much water as possible, and that is by preventing people from running their taps for sometimes minutes on end, waiting for that hot water to arrive because the distribution system hasn't been properly maintained. So that's really important there. And then we talked about the maintenance of these controls, which is can serve more as a kind of an inspection procedure rather than a kind of a replacement of components or anything like that. So keeping this maintenance in mind and what we've talked about today, are there any questions or anywhere that you'd like me to dive a little bit more deeply into, or anything that you'd like to add at this point to talk about the maintenance of these components?
Yeah, we had one question come in here. Someone asked, do I need a circulation pump and a built-up system if heat trace is used for temperature maintenance?
Yeah, there are successful systems without the circulation because of the heat trace, right? You just need to make sure that the heat trace you're using is really designed for this purpose, because a lot of heat trace has its own kind of changes in internal resistance based on the need to prevent freezing in lines. So a lot of heat trace is designed to maintain above 32 degrees water temperature, while the heat trace in a temperature maintenance system needs to be designed to maintain 120 degrees. So it operates a bit differently there. So in those terms, you don't need a circulation pump with heat trace because it's providing that heating right in the line rather than pumping that water back to an external heater. But yeah, great question. Do built-in controls on a heat pump have the points you would need to calculate equipment COP? More generally, what I'm getting at is extra measurement hardware to check system performance. Yeah, this really varies with manufacturer, and there are some manufacturers that offer additional components as a factory option to calculate equipment COP. Like, I'll be specific with Colmac because I know their extra options best. They offer an energy analysis package that can be ordered with the system and installed in the factory. So it reports the COP right out to the screen, or can report it as a communication point to the building management system or to an external source. So oftentimes you'll need this additional equipment, but there are additional options with some manufacturers that include it. And how often and under what circumstances do you involve heat pump manufacturers in maintenance? Hopefully, you can just get the information through the manufacturer documentation, and it should be a talking point during the design. So it could be a conversation with the rep, or if you have had communication with the manufacturer, it could be a conversation with them. But most typically and most efficiently, you're not having a conversation with the manufacturer just to get the maintenance steps if it's clearly laid out in the manual. If there's points that I've covered today that aren't covered in their manual, or it seems lacking based off your kind of intuition of what you think should be looked at here, that's when you need to reach out for additional information, because as a lot of us have seen with submittal documents and manuals, sometimes that is not what the manufacturer has poured the abundance of their resources into. Sometimes there's definitely some lacking information in those manuals. So that's when you would need to reach out to the manufacturer or their rep to make sure that you have all the points you need to maintain if it's not totally clearly laid out in the manual there. And sorry, the other time that I've seen the manufacturer pulled into maintenance is when the tech is actually performing the maintenance procedures and there's a question that comes up or an issue that comes up with the equipment itself and it's not acting as it should, then it kind of turns into a troubleshooting process in where a manufacturer's tech should certainly be involved to verify that the equipment's operating as it should. Yeah, and any more questions that remain, definitely drop those in the chat, but I'll go ahead and move on here. So now we can look at a review of our 4-part series of design, maintenance, and operation. So some of the newest information in this series is, and newest to a lot of you listening in, is the 4 commercial heat pump water heater system components and how important they are to contributing to the system. So there's the heat pump water heater itself, which is, an obvious, when you think about a heat pump water heating system, of course you think about the heat pump water heater that is the heart of the system that needs to be accommodated by all of the other components that are, I would argue, is equally as important to think about. So there's also the primary storage tank that is paired with these heat pumps that both provide enough hot water during these peak loads when everyone turns on their showers in the morning, for example, but it also helps pair with these heat pumps to provide the right water conditions for the heat pumps to operate most efficiently. You can see in this picture, we have this cold water, this channel of cold water on the bottom that's allowing these heat pumps to always take in cold water and output hot water. And that flow is kind of separated from the supply flow because of the use of this storage. So the heat pumps can always see conditions they'd like to see independent of what's going on in the building. And then we have the temperature maintenance system that, even though there's circulated water in almost all central water heating systems, this is operating a little bit differently because we have a dedicated heating system to accommodate that. And then we have the controls that bring all the equipment together and operate as the brain of the system, and these controls can be part of either the heat pumps themselves, or they can be a separate controller as part of the building management system, or a third-party standalone that looks at all the different components and determines when the heat pump should run. And so there's 4 different types of temperature maintenance systems that have been implemented really successfully, depending on the type of heat pump that you're dealing with. So the first is a dedicated parallel heat pump water heating system, and I'll switch slides back and forth as I talk about these 4, but the previous slide we just looked at is a parallel temperature maintenance system, because this return water from the building is going to a completely separate system that's serving the mixing valve in parallel with the primary storage. So these are two separated functions that are serving this building in parallel rather than being directly interfacing with each other. And the dedicated series or swing tank temperature maintenance system is a little bit different. And that's what we looked at Elizabeth James today. And I'll show you the difference from the parallel system that we're looking at here. So instead of the primary storage directly serving the mixing valve, this hot water coming from the primary storage is going to go into the bottom of this temperature maintenance tank. And the reason it's doing that is because as it passes through this tank at a really high temperature, it's actually warming up all the water around it. So with sufficient hot water usage, your hot water circulation loop is actually being reheated by that primary hot water, rather than needing to have a heater to heat it completely separately in a less efficient manner. And then we talk about a combined primary and temperature maintenance system, and that looks a lot more like your conventional gas system, where this entire tank and heater is completely omitted from the system. And this hot water return is then going to return back to your primary storage. So now instead of the bottom of your storage being this nice cold temperature all the time, you have a cold to warm temperature at the bottom of the storage, depending on how much cold water is rushing in as water is used by the building. Right, so with a combined temperature maintenance system, you have to be really careful to work closely with the manufacturer or their rep to make sure that their equipment can handle those higher entering water temperatures, as well as coordinate closely with the controls to make sure that those tighter tolerances of on and off set points can jive well with this higher entering water temperature to the bottom of the tank. And then the last option is a no recirculation option, which was addressed by one of these questions, where you actually have heat tape or heat trace on the hot water supply pipes rather than having a dedicated temperature maintenance system. So now we're not even circulating water, we're just keeping the water that's being served to the occupants hot, whether they're using it or not. So then the heat pump still sees that nice cold water coming in anytime there's usage, but it doesn't have to worry about reheating that warm circulated water. And we covered 3 case studies in this series, the first being Hopeworks Station, which was a new construction in Everett with 13 different sand-in heat pump water heaters. And they're actually serving, I believe they're serving about 10 different areas in the building with their own supply pipes. And heat trace is used on these pipes so we don't have to circulate the water through that loop. And this works really efficiently because with these the semi-central setup of these water heaters, they're serving really short supply pipes, so that kind of less efficient heat trace is only heating a minimal amount of supply pipe. And these are installed on the rooftop, and they're really small and dispersed throughout the roof, so then you can maximize the amount of solar storage or solar production in this building because they actually had a goal of 0 net energy in this building, which is really cool. And they were able to save 1.2 kilowatt hours per day per person by implementing this heat pump water heating system, which allowed them to meet their 0 net energy goals when offsetting with solar. And then last session, in session 3, we talked about Jackson Apartments, which is a new construction market rate building that used Colmac heat pump water heaters in the garage underground, and that garage was able to serve as kind of a buffer for the incoming air to actually heat the incoming air before it reached the heat pump water heaters. So then the 40-degree minimum temperature allowance that those heat pump water heaters can handle was able to be implemented in Seattle, where we have a 26-degree design temperature. So that 26-degree cold winter air was able to work its way through the garage and warm up to 40 degrees just by passing over that huge mass of cement that's also in contact with the earth that has an average temperature that's a lot warmer than our design cold temperature. And Jackson Apartments was able to see a 15% annual energy savings over the entire building because we're using heat pump water heaters. And Elizabeth James is the retrofit application we saw today, where we have 4 Sandin heat pump water heaters located outside and paired with 320-gallon tanks in the mechanical room. And the existing equipment in that building was used as the swing tank and the swing tank heater, but also provides additional redundance in case a heat pump goes down for any reason. And a funny story about this case study is a tree actually fell on one of these heat pump water heaters. So in talking redundance and the need for it in pairing with heat pump water heating systems, these heat pumps were very reliable, but a tree actually fell on one, which it totally can't be, you can't blame the manufacturer for a heat pump breaking down there. And nobody ever got cold water because that the way that electric redundance was designed just kicked in automatically. So the total energy savings of this building was about $1 or 1.05 kilowatt hours per day per person because they implemented the heat pump water heating system. And in session 3, the content we covered was the transition between design and operation. So getting design drawings from the engineer and tuning in all the details for the equipment to actually allow it to operate reliably in the future. And we talked about the attributes that you want to look for in determining subcontractors for this work, as well as the details that are important to think about with the heat pump water heating equipment and all the components around it, and what you need to verify while you go through the purchasing process of this equipment. We also talked about the installation and startup and some really high-level features you want as part of your installation process. And then today in the maintenance session, we talked about what you need to clean, maintain, inspect, or replace in all these different heat pump water heating components. So these are kind of 4 buckets that we can simplify it down to, but there are specific maintenance lists for each component that are really important to allow the overall system to operate most efficiently. So the occupants are never getting cold water or overly hot water, and so the equipment can last as long as possible. And so here we have an exit survey for you that I'll go ahead and leave open here. We won't walk through the answers, but it's really valuable for Ecotope and DNR to understand what information was helpful for you and what information we might be able to implement into future surveys. So I'll exit out of presentation mode here and keep the survey active while we move on to this last slide and we can talk about some upcoming trainings here. And Trevor, maybe you can talk about what DNR has prepared with in collaboration with Ecotope on this next upcoming training.
Sure, yeah, thanks. I'll pop my camera in here at the end. Thanks so much, Evan, for all the great information, and thank you all for joining us and all the great participation. Yeah, just a note, we do have upcoming here on the December 1st. It's going to be the commercial heat pump water heating systems multifamily. So that's going to be sort of a deep dive into the multifamily applications and how it's different and the different considerations you have to have for it. So it's going to be 10 to 12 on the 1st. I hope you can sign up there just the same way. You just go to the Lighting Design Labs page and just sign up there. The recording of this training will be available on the LDL YouTube channel after probably in a few days. So they're going to put that up, and also the slides will be available on the LDL web page. So please check those out. Yeah, we did have another question here, Evan, too, at the end. Someone was basically asking, like, taking a step back, Do you have an idea of what manufacturers are looking to do in, say, like the next 5 years, or what Ecotope thinks the next 5 years of this this will look like? So, what does the commercial heat pump water heating space look like in the next 5 years, and what are manufacturers looking ahead to?
Yeah, that's a big question, but I'll try to address it appropriately here. So there's the heat pump water heating space is really exciting right now, as there's been a lot stronger look on how to electrify our buildings and how to make them more efficient. So the existing heat pump water heater manufacturers are quickly ramping up to try and meet this new market demand. Well, there's also additional interest from several other manufacturers to get in on this expansion of the heat pump water heating market. So I anticipate that you'll see a lot of big boiler or heater manufacturers start to come out with heat pump water heating products on their own. And that's not based off any crazy intel I have. It's just kind of a hunch based off how these markets are transforming. And in terms of what they're doing to advance the technology, there's a couple of things we're seeing. One is the components for these water heaters are being a lot more finely attuned to actual heat pump water heaters, because if you think about it on a manufacturer level, usually they're buying components from individual vendors to install into their heat pump water heaters. So if there's not a huge market for heat pump water heaters, then these components are initially designed for other applications like chillers and other sorts of applications that use the refrigeration cycle. So now that there's enough excitement around heat pump water heating technology, these individual component vendors, like the big names that give compressors and heat exchangers to the really big manufacturers, are now more finely tuning their equipment to actually be installed into heat pump water heaters. So we're going to see a lot more efficiency out of equipment because of that, as well as an excitement to transition refrigerants to these newer low GWP options. CO2 is a big one that a lot of people are putting a lot of research and effort into, as well as some synthetic refrigerants that are being implemented into new heat pumps. So we're going to see a pretty fast and heavy transition in terms of refrigerants and just overall equipment efficiency and equipment availability, because there's a lot more eyes looking at this heat pump market expansion than there was even 5 years ago.
Awesome, thank you. Yeah, thank you, Joseph, for that question. It's great to sort of get some insight in where the next steps are in this industry. So yeah, I think that's pretty much all we have. Hope everyone was able to fill out that survey. This will be the last one we have for this year. We'll start up again in 2022 with SCL, so we'll have some additional classes there. So keep an eye out. I'm sure you get some emails from them. I'm sorry, for LDL coming up in 2022. But thank you all so much for joining us, and I hope you have everyone has a great holiday.
Yeah, thanks for joining, everyone. Hopefully we could bring some great information for you.
Thanks.